Hi everyone, we'll solve, so this is the class 11, we'll solve the questions, the integrals about trigonometric substitutions. So let's start. Okay, here we're given this integrand, sine cube times cosine to the fourth, okay? These are important identities. You should memorize them, okay? They're so useful while we have such integrals. Okay, what do we do now? We substitute u equals to cosinus theta. Then we differentiate it and get minus sinus theta d theta. Now what do? We rewrite this integrand as in this form. So here we had before cosinus to the 4 theta. And we have sinus squared times sinus theta. Okay, here we have sine cube, so as we had before. Okay, we rewrite it. Now what do? Here we know cosinus theta is equal to u, so we have u to the 4 then, right, for this part. Okay, this is the integral. And what else? Here we have sine squared, right? What's sine squared in terms of u? We know 1 equals to sinus squared theta plus cosinus squared theta. So what do we have? We have then sine squared equals to 1 minus cosine squared, which is 1 minus u squared. So we have here 1 minus u squared. So we wrote this in terms of u. Now what do we have? We have sinus theta d theta, which is from this equality minus du. So here we have minus du. Now if we write this minus outside of the integral, because it doesn't depend on u, so we have this integral then, u to the 4 minus u to the 6 du, okay? You know how to integrate it. We have u to the 5 over 5 plus u to the 7 over 7 plus some constant. We know u is equal to cosinus theta, so the only thing we need to do is plug this equality. Okay, here we have the result then. Now we're given this integral sinus to the 5x dx. We again substitute u equals to cosinus theta and differentiate it. Now what do we have? Here we have sinus to the 4 times sinus x dx, because we had before the power 5. So we rewrite this. Remember, sine squared is equal to 1 minus u squared. So here we have 1 minus u squared to the 2. Okay, because we had here 4 as power. And sinus x dx is equal to minus du, right? So I made a mistake there, but it's not a big deal. So we write instead of theta the x. Okay. So this is then minus du. Here we have minus du. But remember, we need to change the boundaries because we changed the variable. Here for x, we know x equals to 0, so we plug x equals to 0 here and get cosine 0, which is 1. And for pi over 2, again, we write pi over 2 here, cosinus pi over 2 is equal to 0, so we have 0 for u. The boundaries of u are 1 and 0 then. Here we wrote outside of the integral this minus again, so we use this power to we write this expansion clearly. So we have 1 minus 2u squared plus u to the 4 du. Now you know how to integrate it. This gives you u, then u to the 3/3 times u times 2, this 2, plus u to the 5/5 plus, sorry, there is no constant because it's definite integral. Then you evaluate it from 1 to 0, but here you have minus, okay, outside of the integral. So you plug them and get this result. Okay. Now we first substitute u equals to square root of x. Okay, then what do? We first differentiate it as usual and rewrite this integral, this given integral, in terms of u and du. So what do we have? We have sine the 3u times dx over square root of x is 2 du from this identity. We have 2 du, so we have 2 times this integral. Now we will again substitute s equals to cosinus u. Okay, so we differentiate and get ds equals to minus sinus u du. Now we rewrite this integral in terms of s and ds, and here we have sinus, we rewrite this sine squared times sine equals to sine cube, right? So what do we have? We know sine squared is equal to 1 minus cosine squared, which is 1 minus s squared. So we have here sinus u du is equal to minus ds, so we have this one. Now what do? We write this minus outside of the integral and integrate this one, which is so easy. So here we have the result. Now we know s equals to cosinus u. So we plug that one and get this term. Okay. But remember, we are given this integral in terms of x, so the result should be, the answer should be in terms of x. So we rewrite this. We need to rewrite this in terms of only x, which is so easy because we know u equals to square root of x. So here we have the result. Okay, instead of u, we write square root of x. So this we're given now this integral. First, we substitute u equals to sinus theta and differentiate it, get cosine theta d theta. Now what do we have? We have cosinus theta times cosinus to the 5 sinus theta d theta, right? We're given that. So if we write here, instead of sinus theta, if we write u, okay, let me note that here. So instead of this, we write u. Okay, now we have cosinus to the 5u as in here. And what do we have here? Cosinus theta times d theta is equal to du. So cosinus theta d theta is equal to du. Okay. So now what do we have? We have this integral now. How do we integrate it? We need to substitute again this one. We write v instead of sinus u. We need to differentiate it first and get this. And remember again this identity, 1 minus v squared, which is sinus squared, right, is equal to cosine squared. So what do we have? We had before this integral. So we rewrite it, cosinus to the 4 times cosinus u du, and cosinus u du is exactly equal to dv. So here we have dv, and cosinus to the 4 is exactly this. We did before that. Sorry, cosinus squared u squared, right? And cosinus squared is, here we had before, we wrote that 1 minus v squared, so we have 1 minus v squared, so I made a mistake there. Yes, 1 minus v squared to the 2 dv. Okay, it should be like this. So here, what do we have? We have 1 minus 2v squared it should be, and v to the 4. Okay, now we have v minus v to the 3, 2 here 3, and v to the 5 over 5 plus some constants. Now we know v is equal to sinus u, and u is equal to sinus theta. So here we have sinus u, and u was sinus theta. So we have sinus of sinus theta. And for this one, we have 2 minus 2 over 3 sinus cube, right, of sinus theta. And for that one, we have this, okay? So this is the correct answer. Sorry about it. So here we had before this one, we're given this integral, so it is exactly equal to that one, okay? So you see anything is in terms of theta, so we're done. Okay, for that one, we first substitute u equals to x, and dv equals to sine to the 3 sine cube dx, okay? So if we differentiate it, we get du equals to dx, and we integrate it and get this one. So that's convert this equality. It's easy, you can find it. So here we have v then, okay? Now if we use integration by parts, we get this one, u times, here we have, let's rewrite it, u times v minus v times du, okay? This is u, okay? So here we have u, v minus v du, okay? Now let's call this integral, the whole thing, okay, a, and let's first find that, okay? For that, we will substitute s equals to sinus x, then ds equals to cosinus x dx. So here we have cosinus cube. We only compute that one, okay? This part of a. So cosinus cube can be written in this form, and we know cosine squared is equal to 1 minus sinus squared, and sinus was s. Sorry about it, it should be s. Okay, so we have 1 minus s squared, and this part was exactly ds, right? So here we have ds. Now this is a polynomial, it's so easy to integrate it, and you get finally this one. Okay, this is the result of this cosinus cube, okay? Not 1 over 3 times cosinus cube. Now a is this, okay? So we have 1 over 3 times the integral of cosinus cube, which is exactly this red one, okay? So we wrote it here, minus the integral of cosinus x, which is minus sinus x. This one's integral is sinus x, so we have here minus, thus we get this one, okay? Now, so we're given, remember, we're given this integral, and it was equal to this one, so we have exactly the same term here at the beginning, minus this one was equal to here, this term, so we wrote it here. So this integral is exactly equal to this one. Okay, now we're given this integral, we rewrite this. So you know the definition of cotangent. It's cosinus over sinus, so we have cosinus to the 5 over sinus to the 5 times sinus to the 4. Here we then simplify it and get this one, okay? Now substitute u equals to sinus theta, then it gives you the differentiation of that identity, gives you du equals to cosinus theta d theta, And remember, 1 minus u squared is equal to cosinus squared. So what do we have? We have exactly, remember, cosinus theta d theta. From here we have du. Okay, 1 over sinus theta is 1 over u, and we have then cosinus 4. The remaining term is cosinus to the 4, and it is cosinus squared squared. So we have 1 minus u squared to the 2. So what do we have? We rewrite this. We write it explicitly. So here we have this polynomial, and the rest is easy. You know how to integrate them. So we have 1 over u, whose integral is ln of u, and this one is u squared, this one is u to the 4 over 4 plus c, and u is equal to sinus theta. So here we have, if we plug u equals sinus theta, here we have this answer for this integral. Okay, this one is over. So let's look at that. Remember this identity. Let u be tangent theta. Okay, then differentiate it and get this identity. So what do we have? We have, if we write this second to the 4 exactly in this form, 2 times second squared, we have exactly same integrals. Now tangent is u, so we have u squared, and second squared is, by using this identity, equal to 1 plus u squared, and from this identity we get second squared times d theta is equal to du. Okay, now we distribute this one to parentheses and get u squared plus u to the 4. So we integrate it and get this one. Remember, u is equal to tangent theta, so we have that. Here's another example. So here's the gift for Christmas for you. There's a hint. Okay. So let's look at this question. Now we will substitute u equals to cosinus x. Okay. Then what do we have? Du equals to minus sinus x dx. Remember, sinus 2x equals to 2 sinus theta. Sorry, sinus 2 theta is equal to 2 sinus theta cosine theta. So we will use that to rewrite this integral as in this form. Okay, now what do we have? We have cosinus to the 3 times sinus x dx, and we wrote 2 outside of the integral. Now remember, sinus x dx is equal to minus du. Okay, so I made a mistake there, of course. Here we have minus 2. Okay, and this is minus du. Okay, and cosinus to the 3 is u to the 3. So we have this and this. Okay. Now we have tangent to the 4 as integrand. We rewrite it as in this form, tangent squared times second squared minus 1. Remember, second squared minus 1 is equal to tangent squared, so we have exactly the same things. So then what do? We have, we rewrite this, we distribute it into the parentheses and get this integrals. So if we substitute u equals to tangent t, we get this differentiation. And what do we have now? We had before these integrals. Okay, these ones. So tangent squared is u squared, right? And du is equal to this. So we have exactly this integral. And for that, we rewrite it as in this form. Second squared minus 1. Okay. We cannot substitute u squared there because dt is equal to then du over second squared, so it wouldn't work, okay? That's why we rewrite it as in this form. How do we write it? Using exactly this identity, okay? So here you can easily compute and get 1 over 3 minus this one. So from this part, the second part of the integral, you get pi over 4. And for this part, you know the derivative of tangent is second squared, so it is equal to this. And the rest is easy. You evaluate for the boundaries and get this one. So the given integral is equal to this answer. Again, you have another homework and also hint. Okay, this is so useful to get that. Okay, and sorry about the light of the page. So we will evaluate the given integrals, but before that, here is a table for trigonometric substitutions. You may use them. Okay, we will back there, so don't worry. We're given this integral. Notice that we have in the denominator square root of 36 minus x squared. So it's of this form, right? Here a and b are constants. Here we have a equals to 6, right? The square of 6 is 36, so a is equal to 6 and b is equal to 1. So here what do we have? We need, it says, the table says that you need to substitute x equals to 6 sinus theta, okay? So as table says, we substitute this one, okay? So if we differentiate it, we get that. Now what do we have? We had before this, so x is equal to 6 sinus theta, so here we have, and dx equals to this one, so we wrote here, okay, and x squared is the square of that, so we have this. Now if you rewrite that, this square root, you have in the parentheses of 36, you get this. And remember, this is exactly equal to this one is equal to 6. And inside of the square root, you have cosinus squared, right? So you get finally 6 cosinus theta. Okay, as in here. So what do we have? We have 36 here. Okay, then sinus theta, cosinus theta there over 6 cosinus theta from this d theta. We simplify it and this one and get 6 sinus theta. So it's so easy to integrate, right? If you compare with it. So it is minus 6 cosine theta from 0 to pi over that. I forgot about it. So we change, of course, the boundaries. If we equalize x equals to 0, you get 0 there. And if x equals to 3, you get 1 over 2 equals to sinus theta, and you know the boundaries, so you get this, okay? Finally, we have this answer. Okay, now we will substitute for second theta, okay? Again, using the table, you will remark it by yourself, okay? You can actually. So if we say t equals to 4 second theta, then differentiate it and get this equality. So what do we have? dt is equal to this whole thing, and t squared is equal to 16 second squared. And we write instead of t squared again this one, so we get this. Now here, what do we have? Here we have square root of second squared minus 1. Okay, so it is equal to 4, and this is tangent squared theta, right? Remember the identity. So you have this as in here, okay? And here we have 1 over 4, okay? And if we simplify them, you get second theta. And from the square root, we get 4 theta, tangent theta. And in the numerator, we have tangent theta. Okay? Now we again simplify them. Then we have 1 over 16. Okay? And 1 over second theta. And 1 over second theta is equal to cosinus theta. And integral of cosinus theta is sinus theta. So here we have the answer. Okay. Oh, we don't have the answer yet. We have the answer is in terms of theta, but we need to obtain some answer in terms of t. So we need to change it. Okay. How do we change it? We will use triangle. Okay. So we know before we had the substitution t equals to 4 second theta. Okay. Then it means cosinus theta is equal to 4 over t. Okay. Now, here we have theta, the angle theta. So if cosinus theta is equal to 4 over t, then here we have this side should be 4 and this side should be t. Then Pythagoras theorem says that this side should be of this length. Okay. Then again, using this triangle, you get sinus theta is equal to square root of t squared minus 16 over t. Now what do we have? We had before this answer. Now instead of sinus theta, that's why we found it, okay? Because we had before sinus theta. And sinus theta is equal to this, exactly in terms of only t and some constants. So we have this answer now, okay? Now we first plug this one, square root of 5 times sinus theta. We differentiate and get this. So instead of du, we write this whole thing again. And instead of u, we write this one, this substitution. And for this one, we have that. Now it is, in parentheses of 5, we have 1 minus sinus squared, which is cosinus squared. So we have the square root of cosinus squared, which is cosinus theta. And we had before, inside of the square root, we had before 5, so we get square root of 5. Now we simplify them and get this integral, okay? Now we rewrite this as in this form. If you simplify them, you will get again 1 over sinus theta, so it is exactly the same. Now we will substitute s equals to cosinus theta, which gives this differentiation. And note that again, this identity, because cosinus squared is equal to s squared. Okay. Now, what do we have? We had before this integral. So sinus theta d theta is minus ds here. Sinus squared is 1 minus s squared. I don't know if you had seen before these decompositions, but you will, so it's practice, you might say. So here we have minus this integral. We rewrite this as in this form, okay? Now we rewrite this 1 over 1 minus s times 1 plus s in this form. We will get there before after a few class, maybe next week, I'm not sure, but you will understand, so don't worry about it. Basically, you write this. Okay, I will give a table for that too, so don't worry. Okay, so then you will multiply that, and you'll get some polynomial in the numerator, so you will equalize it to 1 and you'll get the values of a and b. So it will give you this exactly. Okay, but we will see that later, so don't worry, as I said before. So what do we have? We integrate these parts and get this. And if we write s equals to cosine theta, we get this terms. Okay. Now remember that, let me remind you, here we had before the integral in terms of u, so we need to write something in terms of u there. Okay. Again, we will do the same tricks actually. So sinus theta is equal to u over square root of 5. From the substitution, we get this. Okay, again, using the triangle, we get cosine theta is equal to this, which is in terms of u. Then we're done. We write, instead of cosine theta, this one. So we get the answer. I know it seems complicated, but it's not actually. Once you wrote that before, seeing that, okay, by yourself, you will get. So I guess this is the last question, yes. So it's a little bit long, as you see. So we write this polynomial as in this form. So we add and subtract 1, we have the exactly same polynomial. We have the same polynomial. And if we rewrite this, we get this one. Now plug u equals to x plus 1. Okay, then you get u squared is equal to x plus 1 squared, then n du equals to dx. So we have this. This is exactly the expressions in the table, right? That's why we wrote that. We made that substitution, okay? So what do? We write u equals to second theta, right? The multiple of u and here 1, they both 1. So we have 1 times second theta, which is second theta. Then what do? We differentiate first, of course, as usual. So let's rewrite this. U squared is equal to second squared minus 1 we have. Du is equal to this whole thing, and wrote that. Now second squared minus 1 gives us tangent theta, and the rest is the same. What do? We have tangent squared times second. We have second times tangent squared can be written as in this form. So we have this integral. Now we distribute this second into this parenthesis and get this integral now, second to the 3 minus second theta. Okay, so if we write them clearly, explicitly, we have 1 over cosinus 3 minus 1 over cosinus theta. Now let's call this one, this first integral 1, and this one second 2 more. So both of them we substitute s equals to sinus theta. As I said before, by decomposition you get this. Okay. Again, as I said before, don't worry, you will see that. If you didn't, I'm not sure about it. Maybe some of you did. So we have these ones. Now for this part, we integrate and get this. Remember, s is equal to sinus theta. So here we have this minus 1 over 2 ln of this one. You will get ln of 1 minus s, ln of 1 plus s. Sorry, ln from this you will get minus ln 1 minus s plus ln 1 plus s. So that's why you get this, okay? This actually. Okay, plus some constant. Now call this equality star, the big star, okay? Now we need to obtain something in terms of, remember, x, okay? But here we have something in terms of theta. Now, what do? We made this substitution before, second theta is equal to q. Then it gives us, because second theta is equal to 1 over cosinus, so we have cosine theta is equal to 1 over u. Now using the triangle, we get this, okay? Now, if we plug this equality into this big star, then we're done, okay? The only thing you need to do is to write square root of u squared minus 1 over u instead of sinus theta. So I hope you understood well. If you have any question, you can attend the office hour, which is on Friday. Okay, so hope you see you there. Take care.